Okay, this is tutorial number 3 and the first part of that tutorial. So you're asked, you as an engineer will test a material described in table Q1, which describes properties of certain types of material. So we're provided with the yield strength here and a tensile strength, the original length of the specimen, given the cross-sectional area of the specimen. So we have all the dimensions of the specimen. We're given a resistance of that test piece, a breakdown voltage of that test piece, the density of the material, and the specific heat capacity of the material. So then we're asked in the question for the modulus of elasticity and briefly describe the meaning. We're asked for the compressive strength if a force of 30 kilonewtons broke the sample. And also asked to briefly comment on the results, the meaning of the results. This is typical of these kind of questions, so just don't forget to actually do that and comment on the meaning of the results. Part 3, we're asked for the percentage elongation if the sample broke at an extension of 1 millimeter. And again, briefly comment on the meaning of the results. We're asked for the electrical resistivity. So we're given the resistance, we're asked for the resistivity. And briefly, again, comment on the meaning of the results. We're asked for the electrical conductivity. We're asked for dielectric strength. Again, we're given the breakdown voltage, we're asked for the dielectric strength. And again, briefly comment on the meaning of the results. So when you're asked to briefly comment on the meaning results, really what we're looking for there is, is it a high value? Is it a low value? Is it indicative of a ceramic or a polymer, or so that kind of response. Then part 7, we're asked for the linear expansion. It's the coefficient of linear expansion. If the sample extends by 2 millimeters when the temperature is varied by 10 degrees Celsius. The temperature is increased by 10 degrees Celsius. The sample extends by 2 millimeters. We're asked for the mass of the sample. We're asked for the amount of heat required to raise the sample by 10 degrees Celsius. So that's the amount of heat energy required. Part 10, we're asked for the specific strength. And again, briefly comment on the meaning of results. Part 11, we're asked for the Vickers hardness if the diagonal length of the indent was found to be 2 × 10⁻⁴ meters under a force of 100 newtons. And then finally, you're asked, do the above results describe any particular type of material? So you're trying to gather all the data that you calculated before and try to decide what kind of material that might be. Now, sometimes these questions relate to an actual material, and sometimes they don't relate to any specific material. So what you have to do in that case is just discuss what would indicate it to be a particular material and what would indicate against it. Okay, so we'll start